Hi everyone, welcome to this introduction video. I'm here with Jean today and we're going to talk about the latest Adia Lab challenge on Crunch, which is about causality. Hi Jean, how are you doing today?
I'm good, Max. How are you?
Great, I'm great. I'm excited to discover what's under the hood and talk about this new challenge that we have on Crunch. So I think the plan today should be just talking everyone through the landing page and also showing our users how they can start sending and pushing code on the platform. Does that sound good?
Yeah, absolutely.
Great, so let's go. So first, maybe we should go and connect to the landing page. Jean, I'm sure you're already checking the tab on your computer. So we're going to go through each different sections. I'm going to ask questions on all different things that we're going to show on the screen, and maybe Jean, you will help us understanding what we're trying to achieve here. So first block, obviously we're talking about a new concept that we're bringing on Crunch. I mean, we're not bringing the whole concept, but it's new on Crunch, which is causal discovery. And we are pushing this new, catchphrase, which is the next frontier in machine learning. So it's very ambitious. So Jean, tell us a bit more about causal discovery and how it is absolutely amazing for our machine learning users.
Yeah, absolutely. I mean, we are all really thrilled at Crunch to launch this concept because causality has been something that is very present in the statistic, in the econometric, and in all the field related to statistics. I mean, it's pretty basic, right? Every time someone talks about correlation, the first word that comes to mouth is it actually correlation, or is there causality behind, or it's just correlated, right? There's a whole bunch of great examples about things that are correlated but are not causal at all. And what happened in the last several years is that humanity created a lot of data, a huge amount of data. And by creating more data, there is more and more what's called spurious correlation that can be found. And especially since we are using more powerful algorithm, you can go deeper in the data and you can find relationship that makes absolutely no sense, right? There is this famous correlation that is with the amount of ice cream that's been sold every year and the number of drowning, which makes sense, right? Because during summer, some child may drown, but also you are selling ice cream, but there is no correlation, right? It's not because you are eating an ice cream that you're basically gonna drown. So it's fine, guys. You can still enjoy ice cream this summer. It's okay. Yeah. There is a whole bunch of good examples, and there is a long format about causality that we recorded with Marco Lopez De Prado and Professor Guido Ibens as well.
Yeah.
These contents are super, they're going to go very deep in the concept of causality, so I don't want to go too deep. It's just that I feel, and I think many of people in the field of data science now feel this frontier where we are seeing correlation, we are using powerful algorithm, but we don't really understand the findings, and we don't go the extra step where you really understand why these two things are.
Okay, so it's all about understanding why.
Exactly.
Great. So how do you do this? So I see a very nice diagram on our website with letters and arrows and stuff. So I think it's called a DAG, right? So what is a DAG?
So a DAG is a direct acyclic graph. And a DAG is a visual representation of a causal system. So what you see on the landing page here on the left is a direct acyclic graph, a DAG. And each bullet here, each letter actually represents one variable of the system. It's called a node. And each arrow between these variables are called edge, and they represent the relationship. It means that there is a relationship between these two variables.
Can an arrow go both ways?
No, it cannot actually. That's why it's called a direct acyclic graph.
Okay, so it's a clear flow between variables.
Exactly, but each variable can have a different role, and we are going to dig deeper into that. What you need to remember at this stage is that a DAG is a visual representation of a causal system.
Are we expecting our users to create DAGs?
Yes.
Is this okay? Great. So I guess the documentation will explain how to do this. But can you talk a bit more about the people that design this competition, and also probably the data set? Because I guess that designing a competition is also preparing for a specific data set, if that makes sense.
Yeah, and the data set is going to allow us to understand how we can turn a visual representation into data. And that's quite easy. Actually, if you look at this system here, you see a clear example of how you can represent a direct acyclic graph in a data frame. So each variable here are 0 and 1 and 2. Actually, here there is 3 variable, and there is 2 variable that we try to classify. So we try to understand what's the relationship between these 2 variables according to the other columns, column 0, 1, and 2. So this is one relationship. What is very interesting in this data set is that it's not composed of one data set, it's actually 25,000 data sets. So each data set represents one small system. So what Adia Lab is giving us here is 25,000 causal relationship, so causal system, sorry, that are composed of several variables. What we're gonna have to do is to train an algorithm to classify each variable of this system and try to understand which variable is linked to which other variable, if they are linked or if they are not. Here you have, for example, in this image, one variable that is not linked to the other and 4 variables that are actually linked to each other.
Interesting. I was just talking about people that design this composition.
The dataset have been looked after by some of the brilliant people in the field of causality, including Professor Marco Lopez De Prado, obviously, Dr. Horst Simons, and as well Professor Hidori Benz. These people have clear commitment to the field of causality. They have been writing papers and pushing the field. So it's been a great opportunity. We were not, actually, I must say, prepared to that because that's completely new for us. This field is as new as you for this competition. So it was very challenging, but we got a chance to work with the brilliant mind of the field. So this data set is really top-notch and actually a first of its kind. There's never been a competition about causal discovery. Maybe I can backtrack a little bit and give you a bit more context about what is causal discovery, because causal discovery is actually a subfield of causality, right? Causality is a ground framework that is understanding if 2 variables are engaged in a causal relationship. Then the causal discovery is trying to automatically discover and train algorithm to understand this kind of relationship. So we're going to specifically focus on causal discovery, which is a subfield of causality.
Great. There's a lot of questions that are coming to my mind. I think what could be great, and you mentioned Professor Marcos Lopez De Prado, is to maybe try to reach out to him and ask him the question directly. So let's try to ring him. Thanks for being with us, Professor. I hope you're having a great day in Abu Dhabi. We're very happy to have you with us to talk about the latest competition we're going to run on our platform. We have some questions for you today, but maybe before you want to say a quick hi to our crunchers, to the users of the platform.
Thank you for having me. It's a pleasure.
So maybe we can go back and describe the problem, the problem statement of the competition for the people that are going to see this video.
The problem statement is, can you recover the causal graphs underlying the data generating process of a number of data sets that are provided, in particular 40,000 data sets. Some of them are part of a training set, some of them are part of a test set. But the important here is that this is a supervised learning causal discovery competition. Each of these data sets has a structure familiar with people who have participated in supervised learning competitions. There is an X data frame which has between 5 and 10 columns. This includes all the variables involved in the data generating process and 1,000 rows. And then you have the Y matrix, which is an adjacency matrix that characterizes the causal graph underlying the data generating process. These data sets are provided with features that resemble the characteristics of financial data sets.
Interesting. Thanks for your answer. Is there any key concept that participants should master to be successful in this competition?
Not much. This is a quite open competition. Participants do not need to be experts in causal inference. However, they should be familiar with concepts such as confounder, mediator, collider, parent, child, what a controlling for a variable means, directed acyclic graphs. These are foundational concepts of causal inference, but again, they do not need to be experts in that discipline. More importantly, they should study the existing literature, and in particular, examples of score-based algorithms, constraint-based algorithms, functional causal models. The reason is, the first thing that they should do is to try existing algorithms. Before they go to the extent of developing a new algorithm, they should try existing algorithms, which means that they need to know how they work.
Great, that's good to know, because I think knowing that it's pretty open will, I guess, attract a lot of different people with a lot of different backgrounds. So that's great. Last question for me, and then I will hand over the mic to Jean. And it's a bit like the following of the last question. Would you recommend any resources on causality?
Yeah, there are a couple of monographs that will be helpful. I would be remiss if I don't mention the one I wrote, which is available for free. When you go to the Cambridge University Press website and you search for causal factor investing, you will get a monograph that is free. You can download it. And in that way, you can familiarize yourself with these concepts. Another book that will be helpful is the one written by Alexander Molak. It's titled Causal Inference and Discovery in Python. You may find some other books in Amazon, but I would say that these two are a good start.
Right. So I think we'll share the links with our community. Thanks for those great resources, and I'm handing the mic over to Jean. Thank you, Professor.
By the way, guys, we will have an intervention of Alexander Molak during the competition, so we will have the chance to have some in-depth explanation of those concepts, and I hope that the community will be able to attend. We'll share the link as well in the chat. So, following question, Professor De Prado, what for you will be a great outcome of this competition? What are you looking forward to?
A great outcome would be the identification of algorithms that perform well when discovering the causal structure of financial data sets. This would be incredibly valuable to the investment community in that identifying the causal structure behind observed data sets is becoming increasingly important. These algorithms may be borrowed or adapted from the causal discovery literature, or there may be also the creation of the contestants.
And I think it will be a first step in the world of causality for many of the participants, especially the people of the Crunch community. And not the first step in supervised learning, because that's definitely what we specialize in. But for sure, the causality is a new step. And from that regard, what do you think the participant will gain from participating in this competition?
Great question. Causal discovery and causal inference are becoming essential tools in quantitative investing. So becoming familiar with these skills will help researchers reduce the probability of making false discoveries and avoidable losses that result from misspecified factor models. So it's a great opportunity to get into this discipline and become familiar with these increasingly important concepts.
Yes, definitely. And so thinking further for the people that will come with a causal background, because we also expect to have people that have in-depth knowledge of causality, what will be on their side? What could they gain from this competition, and what should they participate?
So your objective as a participant should be to learn. Regardless of who receives the $100,000 prize, the real winners are those who have learned these new tools and techniques that will make them successful in the future.
Looking forward to that. And finally, could you give us a word to the participant, whether they come from the machine learning or causal community?
Yeah, participating in data science competitions like the ones that CrunchDAO organizes is a sure way of strengthening your credentials, your CV, and standing out from the crowd. This is a one of its kind competition. I'm not familiar with similar competitions that have been set up in an emerging topic, in a topic that has been recognized of critical importance by the investment community. And I hope that you take this opportunity to join the causal revolution.
Thank you, Professor De Prado.
It's always great to have the professor with us. Yeah, and you can see that is really excited about this new competition, and that having the opportunity to work with our community is also, even for him and the background that he has, always exciting, because new things can come up from this.
Absolutely, and actually I got the same feedback from Hido Ibans. Professor Hido Ibans gave us the same feedback in the interview we have. I think this is an opportunity to lay out new techniques and really make an advancement in this field. And it's critical because, like I said before, more and more data have been created. We are using more and more complex algorithms, and the implication of not understanding the behaviors of those algorithms is problematic. Thanks to causality, you can also make links behind certain decisions that can be made algorithmically by machine learning algorithm, and that's actually very important for the advancement of both machine and the interface between machine and humans.
Would you say that causality, understanding the cause and effect, is actually a way to make machines truly intelligent?
Well, at least we would have to define what is intelligence, but
definitely not me.
But for sure, an algorithm that works purely on correlation is going to be very stupid. And especially if he has access to all the data in the world, he will find relationship everywhere between things that make no sense, and he's going to take decisions that are absolutely stupid. So for sure, not having causal algorithm in decision making is
a risk.
It's a big risk. Yeah.
Maybe we can talk about something would be out of interest for our community, obviously, which is the prize pool. So if I read the website correctly, there's a grand prize of $40,000, and then we have a full, leaderboard. And I guess we want to reward the first 10 best submissions. Is that correct, Ron?
Yes, correct. So here again, I think the goal behind this competition is to find a diversity of solution. And by rewarding the top 10, we try to make sure that there are going to be prize for people that put sweat in the competition, not only to the top one and to the first solution.
Now that we've kind of went through the entire website, our users would like to see you show them how they can submit some code, right?
Yes, absolutely. And the word code is important here. This is a code competition. Why a code competition? You guys probably already participated in data science competition. This is not a data science competition. This is a Crunch. And in Crunch, we are collecting code because we want to test your code in data that your algorithm would never have a chance to train on. And that's very important. We're going to be able to run a ton of tests, and we're going to be able to really make sure that your solution is robust. So it's a code competition. Who say code competition means that it's going to be a bit more complex to submit, but we try to keep things simple. So let's go on my screen now. If you are on this page, it means that you already accepted the rule of the competitions, that you already created an account. Here you have a clear description of what is the use case, how you're going to be evaluated, and what's the expected format. I don't want to dive too deep today in these technicalities, but we're going to have a complete tutorial and a deep video about what's the format, what's expected, how to make sure that your code run, and how to go a bit deeper in the data. So now how to submit. You have a submit tab here. You're going to have to click on reveal the command. This command is allowing us to identify your account and make sure that you are entitled to download the data. By clicking the copy button and by opening the quick starter, by clicking on this link, you'll be redirected to a Google Colab that shows you a very basic submission. That's what we call the quick starters. So quick starters are basically a way to get into the competition easily, make sure that works, that your setup is compatible, and that you can actually run through the competition. So first column, here we are installing the Crunch CLI. The Crunch CLI is actually the library that you need to download the data. And we are also installing a library here called gcastle. Gcastle is a famous library for causal discovery. And we're going to build the first solution in this quick starter using this library. Second cell you're going to see in this Python notebook is your setup command. So the command I just copied from the website, I just passed it here. And by clicking Magenter, you know how notebook work. I will basically set up and authentify myself using the Crunch CLI. So here, making sure that everything goes smoothly. The script is currently downloading a main.py, which is a basic example. It's downloading a notebook.ipnb, which is also a basic example. The same one, but in different format. And the data. So you'll find 3 data sets. One is called the train dataset. The other one is a test dataset. It's downloading right now. 95%. Okay, here we go. Success. If you see success here, it means that you downloaded the data, you authentify yourself, everything is going smoothly. Now, if you don't see a success here, try to copy again the notebook submission command here and try to make sure that you actually have the latest token.
Oh, yeah, and by the way, just a quick question. Where's the best place to reach out to someone if we're struggling with this technical phase?
So definitely Discord. Anyway, join the Discord channel, not only for getting helps, but just to engage with the other participants to know what's happening. There is announcements that are happening almost every day. They're going to be the links to the lesson. They're going to be the links to the documentation. They're going to be all the participants basically in the same channel. So please join the Discord channel. You have a link on the hub. You have a link in the email you received. We are waiting for you there. It's very important. There is a channel called Debug that you can just ask any kind of question over there.
Great. Good to know. Yeah. Let's go back to the platform now.
So basically, once you have a success message here, it means that you are all set up and everything is going smoothly. Next cell, I'm importing the library that I'm going to use. You probably know most of them. This is very basic. And I am loading the Crunch CLI to work in a notebook environment. So this command is basic, just execute it. And if you see loaded in line, it means that you are all set up to work. Here you have one test function that is just checking that all the direct acyclic graph that you generated are actually acyclic. So you see that this function is just going through every node, and that is making sure that this node is not interacting in both ways, like you just asked. So use this function. It's pretty efficient. You don't have to come with your own testing function for the acyclicity. This one is working fine. Then you find the train, infer, and test function. Those one are what we call the interface. So the interface is how your code is going to be called. So you have to put your code into this function. It's very important. First function is the train function. So train function is basically just loading your model, instantiating a model, and training it. Infer function is opening the model and creating a prediction file. So here we can see that at this line, we're actually going through the 25,000 data sets. And by executing the function, we're going to see the first one that I print right here. Oops, let's run the test. All right, while it's running, I'm gonna add a few comments. Number one, you have to make sure that the library you're using has been whitelisted. And to make sure that the library you're using are whitelisted, you have a tab here on the front where all the library that you can use are currently listed. If you want to add another library, just ask on Discord and we will check, make sure that the library is safe and can be used during the competition, and we will allow it. All right, here my code just run, and you can see the first of the 25,000 dataset appearing here. Now, let me download this notebook, clicking on File, downloading it. IPNB. All right, now let me go back and submit this notebook. Let's call it first try, and let's submit it to default. Now, next step, very important step. You need to make sure that your code is actually running on the server. So you need to hit this button, run in the cloud, and you'll have to answer a few questions. First, did you run a local test? That's the basic things. If your code doesn't run locally, it's not going to run on the server. Hit yes if you did. Second question, are you going to need a GPU or CPU? We are automatically going through the code and making sure that if you are not using GPU library, we're not going to affect you a GPU. Now, we may be wrong, so ask on the Discord if you need a GPU, just let us know, and we will manually affect you to a GPU instance. Hit yes. Are you sure you want to create a run? Please don't overuse run. Basically, every time you're going to hit this button, you're going to create an instance, we're going to fire an instance, we're going to connect hardware to it, and these are the cost. Let me create. We just created a run. And in this page, I will see all the log of my run appearing one by one. So let me see another one. Let me check another one right here. That already ran. All right, let's see. Here you can see an executed run. If everything went smoothly, you will receive a success status here. My run is in success, so I am all okay. The code is running, and I still have quotas on the platform. That's a very basic run through the platform. We will go deeper, Max, and run full tutorial and full data exploratory. But for the moment, I think that's a good start.
Yeah, I think that's a great step. Thanks for joining us today, Jean. That was a great, walkthrough. I'm sure that we'll have a lot of questions, and we'll be happy to answer all of these questions on our Discord channel. And also, again, a huge thanks to Marcos Lopez De Prado for joining this video. And yeah, let's crunch.
Thank you, Max. Bye.
Bye.